Building on that idea, a standard changes catalog with clear guardrails creates a shared playbook for everyone touching production. Each type of change, such as patching a library or adjusting a configuration file, can be classified and documented with predefined steps. This catalog limits improvisation by defining which actions are safe to automate and which require human review. Imagine a cloud team adding a new virtual network. If it follows a documented template approved in the catalog, the process is routine instead of risky. Clear categories save time by reducing debate about approval routes. Over time, these patterns build a culture of predictability, where engineers and security reviewers know what to expect from one another. From there, pre-approved workflows for low-risk updates let organizations move quickly without bypassing oversight. Routine adjustments, such as updating metadata or refreshing non-sensitive certificates, can follow streamlined paths. These workflows still record evidence of review and outcome, but they eliminate unnecessary meetings or delays. For example, an automated script might trigger a system patch within set parameters and log the result automatically. Because the rules are well-defined, leadership can trust that safeguards remain intact. This trust encourages efficiency and consistency while freeing human reviewers for higher risk or novel changes. Continuing that flow, peer review gates before deployment remain one of the strongest ways to balance autonomy and assurance. A second set of eyes often spots configuration errors that automated tests miss, such as a missing access restriction or an incorrect variable reference. Peer review should be seen not as bureaucracy, but as a learning exchange. Two engineers discussing a proposed update often uncover small improvements or simplifications that strengthen the system. The review gate also teaches newer staff what good looks like in real configurations. Over time, peer review fosters both quality control and mentorship in the same simple habit. In practice, change advisory checkpoints work best when they are scaled to the impact of the modification. A small patch that affects one internal service should not go through the same scrutiny as a major database migration. The concept of proportionality keeps oversight meaningful. When advisory boards only weigh in on significant or high-risk moves, their attention and advice carry greater value. For instance, before a wide system upgrade, the board might assess rollback readiness and user communication plans. Such targeted involvement avoids review fatigue and preserves trust in the advisory process itself. Extending this principle of structure, infrastructure as code defines desired system states in a transparent, versioned way. Instead of manually configuring servers or networks, teams declare what they want in code and store it in repositories. This makes every environment reproducible and reviewable. When the same script builds production, staging, and development, configuration drift nearly disappears. If a team member accidentally changes a setting, code-based automation restores it to the defined state. Infrastructure as code therefore serves as both documentation and enforcement, bringing consistency that scales naturally with system growth. Building on that, pipelines that enforce testing, security, and compliance checks add automatic discipline to change management. A deployment pipeline can include steps that run unit tests, check configuration syntax, validate access controls, and confirm policy adherence. Only changes that pass all gates progress to production. This prevents the familiar problem of good intentions failing under deadline pressure. For example, a continuous integration pipeline might block a build that includes hard-coded credentials. Over time, these automated gates make compliance an everyday habit rather than an occasional audit exercise. They also capture traceable evidence that each step was followed correctly. From there, artifact signing and provenance tracking ensure that what is deployed matches what was reviewed. Every build output, such as a container image or script bundle, can carry a digital signature that confirms its source and integrity. When that signature is verified during deployment, the system rejects untrusted or tampered components automatically. Think of it as a chain of custody for software, linking code authorship, build environments, and release destinations. Maintaining this lineage protects against supply chain tampering and accidental overwrites. The organization gains assurance that every deployed artifact truly belongs to the approved version history. At the same time, secrets management must be handled with equal precision. Secrets include passwords, tokens, and encryption keys, items that can expose entire systems if mishandled. Centralized secret stores, integrated with identity management, allow applications to retrieve credentials securely without embedding them in code. Automated rotation schedules reduce the risk of old or compromised values persisting unnoticed. A simple example is rotating database passwords every 30 days through an automated vault process. This eliminates manual errors and ensures compliance evidence is always up to date. Effective secret management protects both automation pipelines and the data they handle. Building further, canary and phased rollouts reduce the risk of large-scale disruptions by introducing changes gradually. Instead of deploying everywhere at once, updates begin in a small subset of users or systems. If issues appear, the rollout pauses or reverses quickly. Imagine a new configuration released to 10% of application servers. Monitoring reveals performance degradation, so the change halts before wider damage. These techniques combine automation and feedback to control exposure. They turn deployment into a measurable experiment rather than a gamble. Over time, this practice becomes a hallmark of mature, risk-aware engineering. However, even the best plans face emergencies, and emergency changes require a specific balance between speed and accountability. Time-sensitive issues, such as critical vulnerabilities or outages, cannot wait for standard review cycles. In those moments, a designated emergency path allows rapid fixes under predefined conditions. Yet each such change must be time-boxed and reviewed afterward to confirm its safety and documentation. For instance, a security team might patch a vulnerability overnight and log an after-action review the next morning. This process prevents chaos from becoming habit while keeping systems protected under pressure. Closely related, rollback plans must be rehearsed and documented before every major deployment. The ability to return to a known good state separates disciplined change from reckless risk-taking. Rollback is not merely a command or button. It is a practiced procedure with verified backups, dependencies, and communication steps. A well-documented rollback scenario lets teams act calmly during incidents because everyone knows their role. For example, before a new database schema goes live, the team tests restoring the previous version from backup. Practiced rollbacks create resilience and confidence across both technical and leadership layers. Extending assurance further, change records should cross-link all relevant evidence sources to show a full picture of what occurred. A single record might connect code commits, test results, approval emails, and deployment logs. This web of traceability allows auditors and engineers alike to reconstruct any change's history in minutes. It also demonstrates compliance with policies requiring documented change control. Maintaining this traceable narrative turns record-keeping into a tool for learning, not punishment. When the data shows patterns of recurring issues, teams can improve their processes. Over time, detailed records become the memory of the system itself. In closing, patterns that scale with confidence depend on repetition, clarity, and feedback. Scalable configuration management is less about new tools and more about disciplined practice that people trust. When everyone understands the rhythm, cataloged changes, peer reviews, controlled rollouts, tested rollbacks, the organization gains both agility and assurance. Each improvement reinforces the system's ability to handle the next one safely. The outcome is a living environment where change is not feared but mastered. By treating change as a controlled craft, enterprises turn complexity into continuity. Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.